I realized we didn't do number 11, and also number 11 was not included amongst Mr. Dresch's answer key videos, so I was just going to make a quick one concerning how number 11 could be solved. Now, it might be different from how you did because I might choose to eliminate a different variable, but technically it doesn't matter. I'm going to choose to eliminate the x's. If you eliminated the y's, your least common multiple would be negative 28y and positive 28y. I'm going to eliminate the x's, and I'm going to show my work for how I would do that. So I'm thinking of the multiples of my coefficients of x, which means temporarily at least, I'm not looking at anything except those x values. And I'm trying to figure out how to make them additive inverses, because if I add them right now, nothing gets eliminated. But if I can make one like a 17 and a negative 17, then when I add them, they would eliminate. But I can't turn them into 17 very nicely. So instead, I'm just going to think, well, 3, I'm just going to make a list. I could leave it at 3, or I can multiply it by 2 and get 6, or multiply it by 3 and get 9, or 4 to get 12, or 5 to get 15, and it would just keep going. And the same thing for the 2's. You could leave it at 2, or double it, or triple it, or so on and so forth. What we're looking for is a common multiple. So for example, 12 and 12, that's a common multiple. I can make one a 12 and one a negative 12. It's not my least common multiple though, so I don't really want to use those two. I'd rather use a number that was smaller just so I get smaller numbers, and the least common multiple, the number that's on both of these lists, is the 6 and the 6. So I'm going to choose to make one of my coefficients a 6x and the other one a negative 6x, since I know they both can become that. And I know they're additive inverses. So I don't need this work anymore. So to turn a 3x into a 6x, I'm going to multiply this equation by 2. In order to turn a negative 2x into a negative 6x, I'm going to multiply this equation by 3. But now I have to go back to thinking about everything. I'm going to multiply both sides of the top equation by 2, both sides of the bottom equation by 3. So I will distribute 2 times 3x is how I got that 6x. 2 times negative 4y is negative 8y. And 2 times 0 is just a 0. Similarly, I'm going to distribute my negative 3 times negative 2x, which I already have done. And my 3 times the 7y, so positive 21y. And then also 26 times 3, which is 78. So I forced additive inverses to exist. I'm going to add them together so these eliminate, and I will have negative 8y plus 21y to combine, which is 13y equals 78 when I add those together. So I'm going to take that 78 and I'm going to divide it by 13, and I'm going to get a 6. So my solution has a y coordinate of a 6. And then, of course, because I'm not satisfied with just a y, I'm also going to find the x. So this y value gets plugged back in any equation that has a y in it. Now, personally, I'm going to choose this top one for a couple of reasons. Reason number 1, 6 times 4 would be smaller than a 7 times a 6. So I like smaller numbers. Reason number 2, this one has a 0 in it. This one had a 26. So I just think the math will be easier in the top equation. But it doesn't really matter. So I'm going to plug in my y. So I'm just rewriting the top equation, but instead of a y, I'm writing a 6. And then I'm going to solve. So 6 times 4 is 24. I'm going to add my 24 over. And then I can end up dividing to find that my x value would be an 8. And if at the very beginning, remember how I mentioned you can eliminate the x or the y, if you were somebody who eliminated the y first, then you would have found this 8 first. You would have plugged your 8 back in, and then you would have found the 6. But you get the same answer.